Okay, ready to get started? Okay, you ready? I'm trying something different here. I found this, and I'm thinking, I'm going to start with where this lecture would end, and then go back to the beginning, and see if that will help make sense. Now, for the quiz, there are these three things that you have to know, and these are the three most used and the ones we're learning in for this class. And that is, if you're trying to do what's called a uniform distribution type simulation, normal distribution type simulation, and known probability distribution type simulation. And a simulation could be using all three of these, just one of these, two of these, depending on what it is it's trying to simulate. For example, here's a situation where it's a manufacturing company. The manufacturing company, I think, is thinking about going into a new product. Look, they have the cost involved. We know advertising is going to be, let's say, $600. That's $600,000. Thank you. $600,000. Administrative cost $400,000, and then our selling price $249. But what they don't know is, and you know, from my experience, is you end up having meetings, especially with a new product, and you're going, hey, what could labor be cost? Oh, I'm not sure what labor is, but they came up with a good range. And this, again, meeting after meeting. We think labor is going to be somewhere between $43 and $47 per item we make. We don't know exactly where it's going to fall, but we know it's right in here. And they happen to have been able to put together probabilities of what labor might be. So you're seeing an example of where known probabilities, somehow they were able to come up with these. So this is called a map. And I can tell by looking at this map, see how this goes from, now with Excel, it's got to be between 1 and 0. So you can see 0.55. If it confuses you, get rid of the point. Let's call that 10, or I'm sorry, 0 to 10, right? If the decimal were two places to the right on all these. 0 to 10, which is really 0 to 0.1, 10%. That tells me that somewhere in the meeting they said, we think there's a 10% chance that labor is going to be $43 for every one of these we make. But it could be as high as $47, and we have a, what percent chance is that? 90 to 100. So we think there's a 10% chance it could be all the way up here to $47. And then these always end up representing a 100% chance. There's a 100% chance it's going to be one of these. And just to make sure you're getting this, what percent chance do you see for $45 being the cost of labor by looking at these numbers? 30 to 70. Yeah, 30 to 70, which would be how many numbers are in between 30 and 70? 40%. 40% chance. You get it? So, if I said to you, hang on, 0.25, 0.50, minus 0.25, minus 0.5. There. There's 5 numbers there. And somehow you're given this information, in real life it'd be through meetings and wasting time, but you're given this information and said, hey, we think there is about a 20% chance that whatever's about to take place will be about 25 cents of change or whatever it is. We think there's about a 10% chance it'll be 50 cents, and we think there's a 30% chance there'll be no change. And where am I at here? They got to add up to 100. They'll always add up to 100%. And you'll have these probabilities. 50, what am I at? 60. Let's make this one 25, and then at least 15. Anybody? Is that 100? Confirmation? Thank you. Okay. How they came up with these numbers, they said, all right, we have 100 numbers to work with. Let's assign 20 of them to represent 0.25. Let's assign another 10 numbers to that. And let's do it in a logical sense. Let's start at 0 and just keep moving. So the first 20 numbers, 0 to 20. The next 10 numbers, well, we'll start where we left off, and everybody always asks, what if exactly the number 20 comes up? What does Excel do? It will figure it out. So no big deal. 10 goes to 30. Help me out. I'm starting at 30. What would be the numbers assigned to this?
60.
60. 30%, 30 numbers. 60 to 25 numbers. 85. 85. That's a 60, by the way. 85 then to 100. Now, so it looks like Excel, I'm putting the decimals in now. There you go. How's that? Right? I'm just trying to help you understand why these numbers have these decimals. That's how Excel does it. The PowerPoint doesn't have the decimals, so I don't want you to get confused. There you go. You only have to map it if you're reading a problem or in real life. The probabilities are able to be known through whatever's happening. Or you're given the probabilities. There's a 10% chance. What is known is there's 20% chance it's going to be 25 cents. 10% chance, 50 cents. If you're reading a problem where it's giving you these probabilities, this is what you're going to use to simulate it. And this uses an Excel function called VLOOKUP. That function tells Excel, pick a random number between 0 and 1 and match it up to this map you made and bring back the result that's over here in the third column. For example, Excel says 0.35. I gotta do something odd. 0.37. Excel jumps up here, 0.37 is between here and here, 0.30 and 0.70. It brings back the number 45. Just like that. Next, Excel comes up with a different number, 0.92. 0.92 is between here and here. It brings back 47, it would be right there. And it does this. So that's one of the three things you're going to learn how to use this formula. Okay, now there's two more. In this example, it looks like they're simulating, hey, we're not sure how much parts are going to cost. I mean, we made one of these. We have a pretty good idea. We have a really kind of a range, but talking to different suppliers, we got kind of different prices based on this or that, how much we're going to order. And we know that the parts are going to be somewhere between $80 and $100. Meeting after meeting, we got that range. And we think there's the same probability of any number between $80 and $100 for the parts cost. Could be anywhere in there, we're not sure. When you hear that the same probability for every number, that's called uniform, like a die. The odds of you rolling a 1, 2, 3, 4, 5, or 6 are the exact probability. When you roll it, it could be any one of those 6 numbers. That's a uniform distribution because every side of that die has the exact same probability, 1, 6. That's what's being described here. Every number between 80 and 100, including pennies, have the exact same probability of each other. And that's a formula called uniform distribution. Now there's two different ways, there's so many different ways to write this one. I like this one. The smallest number plus, tell Excel to pick a random number, times the largest number minus the smallest number. Are you ready? Here's an example. What are we between here? $80 and $100. Hey Excel, I'm doing a simulation for parts. I need a number between 80 and 100 that parts could possibly cost. So Excel says, fix a random number, 0.50. All right, so 0.50 times the difference between these two possibilities. What's 100 minus 80? 20. What's 50% of 20? $10. Then add it back to the smallest number. So 80 plus 10 for this sample, we're going to use $90 for the cost of parts. The next trial, Excel picks some other random number and parts cost some other cost now in this simulation. Every one of these rows, rows, are a trial, meaning Excel is randomly picking the things you told it to randomly pick. And it's coming up with whether you're going to make money or lose money based on this combination of randomness. Perfect storm, I call it the perfect storm, is when labor, somewhere in the simulation, it has labor at the highest cost possible. It has parts at the highest cost possible, and it has demand at the lowest possible. And that would be a perfect storm, which will probably end up with the largest loss out of all these trials. And then there's the perfect situation. One of these simulations will have your labor cost as low as possible, your cost for parts as low as possible, and your demand is way up there. It simulates every possibility as long as you All the work's in this first row. As long as you copy and paste it in enough rows below it, it will simulate every combination that possibly could take place based on the information you gave it. Up here. All of this stays, then these are done. There's always looking up here, coming up with these numbers. Here's where dollar signs become very important when you write these. This chapter is all about how to write this, so that this can be calculated, or whatever the objective is of your simulation. All right, let me see. By the way, another way to do this uniform, I think it's called, is it between or in between? Somebody, where's my Excel people? We are videotaping. Somebody knows Excel in here, is it? Oh my God. Well, somebody has Excel open. Try in between for me. In between. And then you would put, is it a colon or a comma? I think it's a comma, 80, 100. Oh no, you would put the cell locations. You always want to use cell locations.
There's no in between.
Isn't it range?
It's not in between, it's then between. Try equals between. You already tried equals in between?
Random.
No, forget random.
I have beta.dist, beta.in, beta dist, beta in, and then rand between.
Okay, forget this one.
Is it rand
Let's stick
between?
with that one for now until there's the alpha.
There's a rand between.
Now. Oh, rand between. I like that. That could be it.
Okay.
That sounds good. Yeah. That one sounds, that could be it. There we go. And then pretend you're doing one and tell me if there's is a comma or a colon between the two cell locations or numbers, whatever. Is it a colon or a comma, you guys? Anyone? Is it a comma? You ready? What's the cell locations I'm going to use here? Okay, this is a uniform distribution. So what would be my cell locations here between with the commas?
E80 and E100, right?
Wherever that 80 and 100 is. E, is that what it is?
Oh, yeah. No, E8 and E9.
E8, E9. And if it's a comma, it'd be $sign E, $sign 8, comma, $sign E, $sign 9. The reason I'm using dollar signs is now that I put that right here, I'm going to copy and paste it all the way down. How many are we doing here? 500 or 1,000? Must be 500. 500. 499 rows below this one. All your work is right here in this first line, and then it's just copy and paste after that. But it will all fall apart. You don't have the dollar signs because you always want it to look up to these two numbers and pick a parts cost that's right there between those two. The third one, and this spreadsheet happens to be using all three, and that's why I like it so well, is they're saying, hey, marketing is at the meeting, we did some research on this product, whatever it may be, and they're the ones actually who helped us come up with the selling price, which is at $249 an item, and they said, we feel very confident, again I lost it, we feel very confident that we're going to sell about 15,000 of these in the first year or two, plus or minus 4,500. Well, that's kind of how it comes about, but that's a pretty simplified way of saying it. And if you feel like that's how the price is kind of being that's how the distribution is being determined or the demand, you go, okay, that sounds like a normal distribution. So around 15,000 plus or minus, like a standard deviation. We're now using this simulation, and we'll use this one to do that one. So this one's using VLOOKUP. This one's using either this little small plus adding the range of the difference, or this rand between. A lot of people like this one. Then this normal is using the, I think it's normal IND, N-O-R-M-I-N-D Excel command, if you recognize it to be like this, a normal distribution. And you'll recognize it in this class, you're always given this information right up here. And how you'll recognize this one and go, oh, this is being described as a normal distribution, it's the only one that will mention a standard deviation. It may mention it as a variance, but you just got to square root it and you know it's a standard deviation. And there was no reason to mention a variance or standard deviation in these. Only this one. You go, okay. When you read these problems, you're being described hey, we need to do this simulation and our passengers arrive following some kind of distribution. And if it says that we think there's going to be a 10% chance that 20 passengers arrive, a 30% chance that 21 will arrive, when you're given probabilities, you go, okay, that's normal. So you need to do something like this that you're about to look at. But you're reading the problem and it's talking about now how many passengers, or I don't know, something else, or how much gas fuel is going to cost for the flight or something. And we know fuel is going to be somewhere between 1,000 and 1,100, and all the numbers in between are uniformly distributed or have an equal chance. We know it's going to be in there somewhere, and everything has the same probability. And you know it's uniform distribution. Something will be said that leads you to believe that the numbers that are being talked about have the same probability of each other. There's no difference. Usually the words uniformly distributed are in the problem, kind of page in. And then you know you've got to use this formula. And there's only 3 of these. And so if it's standard deviation or variance, you know it's this. It says same probability. And if you're given probabilities about it, you know it's this one. For example, I'm going to have my book out, but I just realized I want to make sure you get this. Now, with Chapter 11, I tried to point out the whole point of Chapter 11 was when you're reading the problem is to figure out which kind of service is being provided. And then once you figure out which service, jump into the right formulas. Well, that's almost the same as Chapter 12, because that's really what most students find is the hardest part of these. Is making sure they're using the right one of these 3 for the problem. So let's just look at this for a second. Look, I'm on page 584 if you follow along with your book, and I'm looking at problem 4. Look at the blue box or whatever color I put on. It's gray blue. Anyway, look at the box. All right. I mean, I can just look at that box and say to myself, which one of these 3 uniform, normal, or known probabilities are you looking at in that box? Known probabilities. You're given the percentages. 1%, 4%, 10, 25. You add them up. I don't know why my handwriting's there. Obviously, there's a 6th one. You add them up, they should add up to 100%. That's known probabilities. So right there, you say to yourself, I need to map this. It's called mapping by assigning numbers that are equal to the probability. This leads us right to here. Right? So the story in this example, the first example you have on the PowerPoint, the story says, hey, we're looking at what kind of change is taking place on the stock price. And we're going to look back at the last 50 trades. And here are all the different changes that took place on that stock price over the last 50 trades. And they said, here's how many. We're going to use this information to do a simulation of what the future changes could be for that stock price. And they said, we want to turn this past information into probabilities. And doing so, 4 divided by 50, 2 divided by 50, 8 divided by 50, 20 divided by 50 will all turn into probabilities and up to 100%. Looks like this. 8%, 4%, 16. And then they said, now, and by the way, you may already have these probabilities in a problem you may see on a quiz. You may not even have to come up with these. But you will have to map it. If you're given known probabilities, you got to map it. Because that's where this is all going. That's how you do simulation when you're knowing the probabilities. So you've got to assign numbers. Now look, the decimals are not in the PowerPoint. But realize it's the same thing, okay? Well, if this has an 8% chance and you start at 0, 0 to 8. Left off at 8. And 4% chance, we'll assign 8 to 12, 4 numbers. Start at 12, this has a 16% chance. You keep doing this process, you should end up at 100 or 1.0 if you use Excel. Mapping should not be a problem. You have mapping in your future, on your final, most likely. This is somewhere where I want you to get this easy point or 2. All right, if you're not understanding mapping, then please email me because there's a piece of the puzzle you're missing because this is very easy. It's just assigning 100 numbers based on the probabilities you're given. Okay? Now, let's understand it. Here we go. I want to simulate the next trade. Let's say the price right now is, I don't know where this is going, I'm making one up, $10. $10 a share. Now Excel, simulate that for me, random number, 0.82. 0.82 comes up. What's the price per share now that it's been simulated for one period of time? Where did 0.82 show up? Remember, those are points over there. Where did 82 show up? Where is it at? Come on. What will be the change?
0.2?
Plus, no, that's the percent chance, so that happened to add up to 100%. Here is 0.82, you're right, it didn't show up here. But you got the whole way over here. The price is going up 1/8 of a dollar. I don't know how much that is. Gotta look. 1/8, looks like it's 1/8 of a dollar, whatever. And I'm putting it in pennies. All right, let's try another. I just want to make sure you're getting this. So now the price is at, what did I say, we went up an 8? We're at $10.01 of a dollar. And all of a sudden the next Excel random number is 32. Where's the price going now? Up or down? Stay the same. That's right. 32 landed right here between these two numbers. It's now the next little time period, whether we're doing this per minute, per second, per day. Now the price hasn't changed. We're still up 1/8 of a dollar. You get how this works? This is what Excel is doing in microseconds. It's just going just like we're doing right now over this. So this is where this whole PowerPoint's going. Getting you to understand, if you're given these random numbers, and you start at how much, $23, or is it, yeah, $23 a share, and those are your random numbers, let's see if you can follow along and get to how much the price per share will be after 10 price changes. Is there 10 numbers there? And so it goes like this. We start at 23, the first number says go down an 8. The next number says go up an 8. So we're back at $23, and so on and so on. And at the end of all 10 simulations, looking at the math, you should be at $23.01 of a dollar for the final price. So there's an example. So now let's go back to the book, put this all in full circle. So we're looking at problem 4. You would, and your problem, if this were a homework problem, you'd be asked to map it, and then you'd probably be given some random numbers. And if you map it different than someone else, that's fine, as long as the random numbers fit your map and make sense as to what the change will be. Because somebody could say, I'm going to start here and go, I'll go from 0 to 5, 5 to 20, 20 to 40, 40 to 65, and to 100. They could start at the bottom or something and have different numbers. Doesn't matter, as long as you're assigning the exact amount of numbers equal to the probability. That's what that's all about. That only that many numbers are being assigned. Okay? Do we feel confident we can map anything? For example, problem 6. First of all, would that be mapped? Yes or no?
Yes.
Yes, because you're given probabilities. Everybody see it in the box? And if you were mapping starting at 0, and whatever this is, the auto collision claim, and the payment is going to be 0, you're mapping it using the numbers from 0 to what? 83. Then you go from 83 to what to simulate a $500 payment? 89. You get it. Everybody here can map, right? And after you map, you're given 2 random numbers Excel came up with, and I want to know how much the claim is going to be. And the first random number is 0.91. I gotta look at this. I may have went too far. I meant to say 0.88. 0.88. How much is that claim? You got it. Because you would have been at from 0 to 0.83, 0.83 to 0.89, so 88 would have been the second one, right? Get it? This is too easy, isn't it? All right. You ready? We're jumping to another example. This one. You may be faced with an Excel spreadsheet, and you have to determine what's going on in that Excel spreadsheet. What is being simulated just by looking at it. Whoops, you're not supposed to even be able to see formulas. There. All right? And it's analyze it. First of all, name something that's being simulated. I gotta stare at it for a second. I only see one thing being simulated. What is it? Huh? Cheyenne, you're being shy? Come on. Take a guess. Who cares if you get it wrong? No, she won't. Don't embarrass her. I'm already embarrassing you so that you would give me a reply. It is normal distribution being simulated, but what specifically is being simulated? The demand. Exactly. I don't know why you hesitate. Demand. Demand. And what does it say about demand? That demand could be how much?
100, give or take 20.
Yeah, 100, give or take 20, exactly. And being described here is a normal distribution, which will end up using this Excel command to simulate it. So what's going on here, we're doing hundreds of months of simulation. So we're simulating 1 month worth of time. We're letting Excel randomly select what our demand is going to be. As long as it's around 100, plus or minus one standard deviation would be 20. We're going to learn how to write this, so we're telling Excel to give us a demand. Obviously, this isn't bad. This is more than one standard deviation above what we expected the average to be. Sales were sales. There's something going on here in the story. I can see it now. When demand is higher than the most we could sell, all we can sell is what we have in stock, I see. What happens if it's less? See, if we have demand less than what we have in stock, then that's all we're going to sell. But anytime our demand outweighs our stock level, this is all we can sell. So here's our sales. It'll always be 100 or less, I can tell by looking at this. Profit is probably taking sales times the selling price, or it's not even selling price, gross profit. So there's gross profit 100 times 50. Holding cost. Holding cost per unit 1,500. $15. So something's not going. What is that? Shouldn't that be 100 times that? There's something about the story I don't know here. That doesn't make sense, does it? Something weird there. Shortage cost. So we have to say, oh, we're going to have paying in the Goodwill department. They're able to figure out what that Goodwill paying is going to cost for every person. We got to say, sorry, it's on back order. So 26 back order situations. 26 times, where's our shortage cost? 26 times 30 should equal 794, if someone can check that for me.
That's not right. 26 times 30, you said?
26 times 30, yeah.
780.
780, why is there $6 difference? No, this doesn't make sense. Try now. I don't know what it is. We'll have to go into the formula. But this is obviously the shortage cost or the holding cost being subtracted from this. At least does that turn out right? It does, doesn't it? For our effect. But what's nice about simulation is analyzing this. Or let's go to that first example so you can really see why the simulation is a big deal. Simulation is a big deal because it gives you this. Now here's what happens. I've had this situation. One time, this happened to be where I simulated what I thought was going to be enrollment in a new program we were considering, and then what the cost would be for this program and everything. And when I can't remember details as to what exactly was being simulated, but it allowed you to see every possible scenario where something really good worked out and something really bad happened, where it was the highest cost here, but we had great demand, where this is the lowest cost and we have great demand or average demand. You have every situation when you do, I used to say you have to do 1,000. 500 isn't even enough. But once you do this, you have every situation being simulated over and over again based on this information up here. You then analyze this. Because what this is telling you out here is your percent chance of that being a good decision. Whatever is being simulated, especially when it comes to a decision on whether you want to spend $1 or $2 million on going to this new product or this new program, or whatever it may be, simulating it first will help you. As long as this information is valid, what's happening here is marketing isn't quite in the manufacturing, so they can't give you the whole picture, and they say, well, we know this would sell, this would sell, this would be successful, but they're not sure what the cost would be. They're not sure we're going to truly make profit. Yes, we can sell around 15,000, but does that mean profit? So we got to analyze all the costs involved. and what the overhead would be, and take that into consideration. But once you get here, the meeting where you talk about how this turned out, that's where it pays off. Because you could say, hey, I have 500 of these. I'm going to use an Excel command that will count how many out of the 500 that are at a loss. And then divide that by 500. That's trying to tell us the percent chance that we're going to lose money if we spend this money and go in this direction. And then at the same time, you say, I can also have it count all the time for making profit. Divide that by 500, and there's the percent chance that we're probably going to make money if we go forward with this deal. And I used to always say, there needs to be a 5% chance or less that we're going to lose money, or this is crazy. Because we got to treat this as if it's our own money, even though it's the company's. We got to treat it as our own. And if we lose $1 or $2 million, that's a big deal. Or spend all that money just to lose money, rather than take time to lose it all or right away. So then you look at what's the most you could lose if the perfect storm hits. And you find out the largest loss in that risk. Or you say, and then Marky is always the optimistic person at the table. We go, look at the most we could make. So you find the largest profit amount. And then everybody goes, oh, look at that. We could triple our money just in 1 year. Oh my God. And that's kind of how it goes. And then you got to make the decision. When you guys, I hope you remember at least a little bit of this. It took me like 10, 12 years to finally get I call it a seat at the table, where you get to have input as the direction in which the company's going, that you're involved in the executive committee, and that even though it is weekly or monthly meetings, or depending on what's involved and what decisions have to be made, when you have that seat, you're going to say, okay, I hope you remember some of this, because people at the table need somebody who brings them all back to earth, I guess would be the way to put it. Because there's times where I saw people saying, let's go, we're doing this. They just want to go forward without taking into consideration the risk involved. And that's what a simulation does for you. It helps point out the risk involved. I want to see if this one has totals. There we go. 45 divided by 500. Is it 500 here? 45 divided by 500. That's about 9%, I think. Is that right? Someone check that out for me. 45 divided by 500. It's about 9%, I think. A 9% chance of a loss, to me, is very risky. Very risky. I used to always say 5% or less. Now, when you aren't there to say, don't do this, don't do this. You're there to say, especially my finance and accounting majors, you're there to say, hey, let's see what we can do to change this so that we go into this lowering our risk. That would be the way to help the company when you get that seat. And the best way is to say, okay, hey, who was on this committee that came up with this distribution as to what our parts could cost for this? Let's get back with the suppliers, say, look, we're thinking about not even going through this. Is there any way something could be done that could change this particular raw material, that raw material? And then you'll be surprised. One little change changes the whole thing. And all of a sudden you go, okay, hey, it's been a couple weeks. What do you still think that parts are going to be between $80 and $100 with a uniform distribution? And hey, we were able to get hold of suppliers. We've got this now between 75 and 95. What's nice is if you make sure in all these used cell locations, you only have to go up and change 2 little numbers and your whole simulation changes in a second. And you can go back and evaluate then that probability of a loss and determine if you really should be going forward. Same with this area. Hay production management, you really are for sure labor is going to be somewhere between 43 and 47. We went back, we talked to the union, they said, we put into that some for sure overtime we thought would be in there. We did put a little buffer in there. We really think it will be somewhere between 42 and 46. We changed this. The whole simulation gets redone. Now everybody's going, what is the probability of us losing money? And this goes down to, what are we looking at? 12. Okay, now we got something. If for sure we can get labor to be in that range, and for sure we can get parts of that for those costs, and if we lower our risk down to, what did I say, 10 of these or 12? 12, that'd be what? That'd be, that's still 24%? 2.4%? Wow, that's way below 5. So, you know, now the risk is so low, and yes, this is gonna cost $2 million. And which we happen to have in savings, but we don't wanna risk losing cash, so we're gonna have to get a loan for part of it, or probably most of it, and we're gonna have to pay 7-8% interest on that loan. Back in my day, I was paying like 12-15%. Interest rates were so different back then than they are today. 12-15% interest on that loan, and let's go forward now that we're in reality and we've made some moves to take that risk away. That's how this helps you. That's why simulation is so important in business. Every big business is using simulation on major decisions like this that are going to cost so much money and have the risk of losing thousands of dollars. What's the most we could lose? We could lose $771,000 in the very first year if the perfect storm hits. That's what I call the perfect storm, the largest we can lose. And that probably wasn't exactly the biggest cost and the lowest demand, but you know, based on probabilities, $771,000 loss will be so huge for a company in most cases. You know, if they're spending up $1 or $2 million for this project, to lose over half your money in the first year was devastating. You know, you still owe the money to the bank, whether you lost it all or not. You can't get out of that. Most we could make. Here we go. Everybody's smiling again. Oh, maybe it's worth it. We could more than double our money in the first year. Look at this. Let's buy it. Come on. You know? Or they'll say, where's the number of profit? Does it have the number? Well, the opposite of this, obviously, right? So if there's a 9% chance of loss, there's a 91% chance we're going to make money. Let's go for it. I'm telling you, I'm not gambling a ton of money. If it were my real money, I need more than a 91% chance. Okay. You're seeing, right? Next, let's go back here now. This next example. Oh, you know what? That's where I should go next. I'm going off of this again. Let's go back here. You ready? You're about to see an example of a mapping known probability Excel function called VLOOKUP and how to write it once you've realized you've got known probabilities and you make your map. And then you place your map on the top of your Excel spreadsheet somewhere. Then you write this statement, this Excel statement. You go look at the map. Now use words to describe what goes in these cell locations. Are you ready? Or in these spots between the parentheses. Equals VLOOKUP. You're telling Excel, you put a map up here somewhere, and you need to go look at it and bring back something. Parentheses. RAND, parentheses, always. You're telling Excel by using RAND, parentheses, no spaces, that you want Excel to pick a random number between 0 and 1. Comma. Here's where you put the map location. You want to put the top left-hand corner where the numbers start, not the titles, the number. Right there where the 0.0 is. And then you want to tell where the bottom right-hand corner is, where the numbers are. There's 3 columns in this one where the 00 is, and to the right of where your 1.0 will be. Right there, so what do we have? This is A, why I can't see the numbers. Whatever, A something. What is going on? Why can't I see the numbers? This isn't like the other computer.
Because of your proportion size.
Yeah, is it there now? It will not show it no matter what. Darn. Anyway, it's obviously A10. Colon, the bottom right-hand corner, C14. Let me say again, there's 3 things you got to put in there. One is RAND, parentheses, telling Excel, pick the random number, comma, the location of your map, top left-hand corner, colon, bottom right-hand corner, comma. The third thing is you're telling Excel where the information is, which column in the map to bring back. Some people put this information in the first column and the random numbers over here. Some people have the information here and have the random numbers over here. So you're putting a 3 if you make the map like this. Telling Excel the information I want you to bring back is in column 3. Okay, it knows then the random limits are in columns 1 and 2. If you said gave comma 1 at the end, it would know that the random numbers are over here in columns 2 and 3. That's how you write a VLOOKUP. There's one of the three. Next, here's uniform. And notice it's using this formula up here. The location, the cell location where the smallest number of the range of the uniform distribution is, plus, is it using, so this is taking the range of the largest minus the smallest first, then multiplying times random number. Order of operations, you're going to get the exact same answer, same thing. So it's the range of the largest minus the smallest times the random number, then it gets added back to the smallest. By the way, I've seen this where you put the largest minus the random number times the range. Still, you're getting a number always between 80 and 100 or whatever the range is. There's so many different ways to write this. And again, there's this rand between, where you can put the cell locations of the smallest and largest of the comma between. So you have all kinds of options, but basically, if you recognize uniform distribution is being described, and you want to simulate it, you got to use one of these formulas. And if this is a quiz, it'll probably say, this is uniformly distributed. How would you write this if the smallest value is in cell E8 and the largest value is in E9? How would you write this to simulate a uniform distribution? You'd say, any one of these, as long as you're using E8 and E9. Okay? Last is a normal. Here's how it looks in Excel, using normal IMD. You're saying, okay, I'm going to simulate a normal distribution, and I know that this problem's telling me it's normal because it's including a mean and a standard deviation, or a mean and a variance, and you just got to square root the variance to get the standard deviation. And so you're writing this formula telling Excel it's a normal distribution with a mean and a standard deviation by writing equals NORMIMD parenthesis RAND parenthesis parenthesis. There's your first spot, comma. Where is the mean? $E, $13. Comma, where's the standard deviation? $E, $14, parentheses. That's the information you need to simulate a normal distribution. Those are the three. That's it. Normal IMD, uniform distribution, and VLOOKUP. That's the only thing you got to learn. You recognize what it is. If you have a good description in words how to write this, like I would have wrote VLOOKUP, parenthesis, RAND, parenthesis, comma, location, the top left-hand corner where 0, 0 is or something, colon, location of bottom right-hand corner where parenthesis, and then either a 1 or a 3, depending on what column you want the information to come from. If you wrote out words like that, this will be very easy for you to write a VLOOKUP for anything. The words here, smallest number of the uniform range plus RAND, parenthesis, parenthesis, times the largest number of the uniform range, or the cell location where the largest is, minus the cell location where the smallest is. If you write that out like that, you could do any of these. And then the normal IMD, you just say RAND, parenthesis, parenthesis, comma, cell location where the mean is, comma, cell location where the standard deviation is. You can write any of these. I want to find one more here. Here we go. Ready? Just to show you, I'm on page 585, number 7. I just glanced at it. I don't know what it says here. I'm jumping to like the first sentence. In fact, the exact time required, I will not say this one. Normally distributed. Let's pretend that's not there. It says, in fact, the exact time required has a mean of 15 minutes and a standard deviation of 3 minutes. Then it goes on to say, you need to simulate that. And you say, you said, well, your mean, I put it in C3, and the standard deviation I put in C4. And then you would just write your V or your abnormal IMD and put C3, comma C4, where the mean and standard deviation is located. You can write that simulated statement. I'm probably making this too easy. I just don't want anybody getting confused. I'm really, huh?
That's what you said last.
Well, I thought I was. I didn't even include you in this. What are you talking about? It was even. I don't know. You see, though, how you're able to recognize this? And then this question is saying, now use these random numbers to simulate this. So you would say, okay, just, you can even send me an Excel spreadsheet that you have normal, INV, RAND, and if you're not using, parentheses, almost forgot. And if you're not using cell locations, what are the numbers? 15 and 3, 15, comma 3, and now you're going to put the numbers in there. 0.1562, let's see what the answer is. 0.9821, see what the answer is. 0.3409, that easy.
Where are you putting those numbers?
Right there for, instead of
Inside
RAND, parentheses, it's giving you the random numbers to insert there and see what you come up with as an answer. Instead of randomly, it's giving you the random numbers and then you insert it, see what the result is. You'll all get the same answer as long as you all have the same mean, same standard deviation, and you're using the same random number. Like right now, if there's 3 people with Excel, they put that in and then put, instead of RAND, parentheses, they put 0.1562, they're all going to have the same answer. And it's going to be somewhere around 15 minutes, let's see that, so that's plus, yeah, it's only slightly above 15 minutes, not even 16 minutes, like 15 point something minutes if somebody does it. Because that's the amount, that is the amount of the Z, like 1 or 2, part of 1 something standard deviation above the other.
So on the quiz, if you give us that as a problem, for instance,
Yeah.
when you give us these random numbers,
Yes.
we just write that down and then put in parentheses under that 0.1562.
Right.
That equals.
Yes,
You would accept that.
absolutely.
Okay.
Yeah, you get it.
Okay.
Absolutely. Or let's say we're doing, yeah, let me find those. Okay, we'll do this one, I guess. We'll go back to this one. Or this one, I may say, map it, and then here are 3 random numbers, and those random numbers, as long as they match your map as to what the result would be. So let's say you mapped it, most people always end up starting at the top and go 0 to 83, 0.83, 0.83 to 0.89, and so on. And then the random number I give you, let's say I say 0.88, as long as I'm going to look at your map, I'm going to look at 0.88, and as long as you came back with 500 as the payoff of payment, I guess, for this claim, and it matches your map and that number, that problem's correct. This chapter's almost too easy now. I can double chapters. We can take Thursday off. Just kidding. Stop. I want to find a uniform real quick. I know it's right here because, hang on, let me just grab a uniform. Watch the words. It'll probably literally say. Oh, geez. I read all that. It's just telling me how to map it. Okay. No? Okay, here we go. Found one. Okay, I'm on, oh, I got it on screen. Problem number 11 right here. Ready? The analyst is willing to assume that the change in price for each quarter is uniformly distributed between -8 and 12%. So we got -8 and 12. That's a bigger range than it looks because negative and positive. So you got all 12 plus another 8, 20 in between. Uniformly distributed. So if this were a question on the quiz saying, now simulate this. If this were on Excel, for example, instead of using cell locations, maybe use -8 and 12. Actually, if this were a test question, it would probably say -8 is in cell C12 and 12 is in cell C13. Now write, and you could come up with 3, 4, 5 different answers based on which one of these formulas you use, but as long as you're using the correct cell locations correctly, you'll get it right. And yet somebody else could have a completely different answer because they use this formula instead of that one, as long as they're using C12 and C13 correctly. So let's write this one using rand between. This is almost too easy. Between -8 and 12% equals RANDBETWEEN, parentheses, what would be there? $C, $12, comma, $C, $13. That's it, you got it right. And it will tell Excel to pick a random number between -8 and 12. It will come back with a random one. Yeah, let's use it. So this would be what? $C, $12 plus RAND, parentheses. Don't lose an eighth of a point here and not put the star, meaning multiply. Excel does not know how to read, how to multiply without that star. They can't be just next to each other. Excel will say, yeah, you can't, it's not like writing an algebra problem where you put them right next to each other. You must use that star to mean multiply. Parentheses, C13 minus C12. Is that right? Oh, $C, excuse me, $13 minus $C, $12. Yes, the dollar signs. Because all of these spreadsheets are always referring to the raw data that you put up top, and where's a uniform? Every time this does this, it has to look up at these exact numbers right here. So for every one of these, there has to be a dollar sign with the cell location, letter and number, so that when you copy and paste this, they're all going to look at that 1800. It won't change that way. That's the whole point of the dollar sign, so it doesn't change when you go to paste it. 1,499 more times. What's the last one now? We did this as uniform. Which one did we just do also? Which one of these two did we just do? This one, so we still got this one to review. You ready? No, we did that one. Shoot. You gotta do the normal one. We did all three. We're done. We're done so far. Look at the time. We're getting this. Now we're gonna go on to the second example on the PowerPoint. The only problem I have with this PowerPoint is that there isn't an example on it for normal INV or uniform distribution. So that's why I really wanted to highlight these, because you won't find it on the PowerPoint. Matter of fact, I wrote down the page numbers, and I find what's in the book even better here. Uniform, the formula is on page 557, and the really good examples on page oh no, I don't know what number 14 is. Me wanting to use it as an example, I guess. Normal distribution. Okay, the really good example it says on my notes here is on page 588, number 17. I'm using something special about that one. And then this, known probabilities, is on page. Got a good example, I guess, on page 586, number 9. Okay. Matter of fact, I know I said I'm going to talk about this point, but I just saw in my notes that I wanted to review some of these. Oh, I almost forgot to tell you. I posted, oops. I don't know if anybody's gone there. Whoops. But I posted a new estimated rate total. And this time, and by the way, we have less in-class assignments and homework than first predicted, so the weights went up a little. I don't know if you guys realize that, which is good for most people. That actually, you guys have such good grades going on your homework and in-classes that it helped kept your grade up, even if you fell apart a little bit on this quiz board. So, I went ahead and inserted the weights for Chapter 10's in-class that we're having on Thursday, Chapter 10's homework that's going to be due a week from today, Chapter 12's in class that's due, that will be a week from this Thursday, the last lecture, and then participation score and final exam. So you can estimate scores for these, which a lot of people do because they like to then start putting different scores in for the final exam to see what the overall grade is. What do I need? What do I need? Blah, 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 So I got that all filled in for you. If you want to see your weighted total right now compared to what it says on Blackboard, you just have to blank out underneath quiz 4 down. Just turn those all to blanks, and then none of this stuff will matter. And we'll just turn this into blanks and turn these into blanks, and then these numbers will match up exactly with what it says on Blackboard as to what your weighted total is. You guys did, everybody looked at the weighted total, right? Okay. Because that's the, you can see, I can see, this class overall really is doing better than most classes have done in the past, so that's good news. And everybody's passing. It's actually very rare for everyone to be passing, so that's great news. I'm happy about that, I think. Right?
Yeah.
Okay, making sure, okay. All right, so, I'm making sure everyone's passing, I'm pretty sure. But, look at how much weight this is. That's a lot of pressure. don't fall apart at the end. This can have has such a big effect on your grade, and that's how important this is. And if you're worried about it, I just told Taylor, a study group is what I would do. Study group, study group, study group. I would do a study group before the final.
Every day for a week.
Well, at least 2 or 3 meetings, and just start doing example problems together. And if you're somebody who feels like you don't need a study group, help the others by going to that study group and help them, because even if you usually do well on the quizzes, it will improve your grade in the final by being part of a study group helping others. All right, now we're going back to public. All right. Here's an example where this plumber says, I gotta buy a bunch of materials for all my jobs I gotta do. I'm gonna look back at history as to what city I'm in out of these 3 cities in the past, and so that I can determine my day-to-day schedule, make sure I buy the right stuff, I guess. So this is what the plumbers come up with, the probabilities, based on looking back at the last like 100 days and saying, if I were in Austin, always look to see where he was, and then he counted how many times he would be in any of these cities the next day, including staying right in Austin, which had the biggest probability. Went back through the same 100 days and said, now I want to look at every time I was in San Antonio, and then counted how many times he was in these locations the next day, including staying in San Antonio, and came up with these probabilities. Same with now Houston. Went back the last 100 and did the same thing. 100% probabilities, they all up to 100, but we have 3 simulations going on at the same time. There's 100%, 100%, 100%. What you need to recognize here is that you need 3 maps. You need a map for Austin, you need a map for San Antonio, and you need a map for Houston. And to make sure you understand what I mean by map, I want to make sure we're all on the same page. Let's just talk about San Antonio. I'm sorry, Austin. You're starting to write your map, and you start right here. Your map then goes from 0 to what? 60. You start at 60 then, and you go, well, if I'm in Austin, there's what % chance of going to San Antonio? 15, so 60 to what?
75.
75 to 100, or 0.75 to 1.0. You get it, right? Then you do the same thing for San Antonio. Then you do the same thing for Houston. They all have to 100. You have your 3 maps. Here's the tough part. You now have to write an Excel function, which I was about to review. And in this case, it's got to be like an if function. There's if functions are used so much in simulation because you're telling Excel, go up and look at one of these 3. You've got to tell it, look at where I was yesterday. Then go up and match with one of these 3 maps. Now that you know which map to look at, pick a random number and estimate where I'm going to be the next day. So here it is. Here's the maps. You're telling Excel, you're writing a statement to go look at a certain cell location to see where you were yesterday, and it says you were in Austin. Then you're telling Excel, pick a random number, and it comes up with 0.55. And then you're telling Excel, bring back what city I'm in tomorrow based on that simulation, random number 0.55. Where am I at tomorrow if I'm in Austin today? Austin again. You get it? I didn't hear everybody, so I think I lost a couple. Are you ready? If you're in Austin today and you came up with a map going 0 to 60, 60 to 75, 75 to 100, you mapped it. Now you've got to write a function that says, hey Excel, go look at where I'm at yesterday. And it says it's in Austin. Now go and tell me where I'm going to be tomorrow based on a random number. And it comes up with 0.55. It says, oh, 0.55 is between 0 and 60, or 55. Between 0 and 60, you're going to be in Austin. And it brings back the word Austin. Now, you've got to turn this all into an if statement where it goes up and says, look at Austin. If it is Austin, then go to this map. If it's not, go to this if statement. Tell Excel to go look up above and say, is it San Antonio? If it is, yes, go to this map. If it's not, you're telling it another if statement. And this if statement says to Excel, go and look and see if I'm in Houston. And you know it has to be Houston. Because if it got to that point, the if statement said, no, you're not in Austin. So it went to another if statement. No, you're not in San Antonio. You might as well not, I take back the if statement. You don't need it. You know you're in Houston. So you just write out, go to the map for Houston. That's kind of in words what you're going to write as an Excel statement. But think about how much is into that. So here's what it looks like. Here's our three maps, right? 0 to 60, 60 to 75. There's the other map, there's the third map. Here's the random numbers you're given. Because this is, it's like an assignment. You're given the random numbers. Now you're going up there. Let's pretend we started in, what's the first one? Austin. Look at the first random number, 93. Where am I at tomorrow? Houston. Now, go to Houston's map. The next random number, 63. Where am I at tomorrow? Wait a minute, where's Houston?
Houston.
Yeah, I'm at, we're over here. We went from here, and it said we're going to Houston. So now we're at Houston, and now it says we're staying in Houston, right? Is that where the number landed? So stay on Houston. The next random number is 26. Where am I at tomorrow? Houston still. Stay on Houston. The number is 16. Where am I at tomorrow? Now go to San Antonio's map, which is in the center. The next number is, I forgot where I left off. 21. Thank you. 26. Where am I at tomorrow? Stay on the San Antonio. The next number is 70. Where am I at tomorrow? Stay there. Next one's 55. Where am I at? You get this. And by the end, we should all be at the same location if you did it right. And so here's what it looks like. Houston, 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 San Antonio, San Antonio, San Antonio forever. Then Austin, Austin, and we ended in San Antonio. If you followed it, if we kept going for all 10 of them, the 10 to all 16 of these, this is where we would be. How is this done on Excel? That's the part that's hard. You ready? Here is what it looks like on Excel. Look at the cell locations. This map, it doesn't have to be exactly like this, but this map is described like this. VLOOKUP, parenthesis, RAND, parenthesis, parenthesis, comma, A6, colon, C8. The next one, equals VLOOKUP, parenthesis, RAND, parenthesis, parenthesis, comma, what do I put next? D6, very good. Colon. F1? F8. That's right, here's the bottom of this one. F8. Comma, I almost forgot back here. Comma, what's the last digit? 3. 1, 2, 3 columns. The information you want to bring back is in the third, so 3. What about this one? What would be the last digit? Comma? 3. What's the last digit on this one? 3. Okay, let's do the first part. Equals VLOOKUP, parenthesis. What's next? RAND, parenthesis, parenthesis, comma, what then?
G6.
G6, but dollar signs, of course. Colon, then what? I8, comma, 3, parenthesis. You got it. Now, here, we're at this spot right here. Current location, we're in Austin. Random number 64. Next day, we're in San Antonio. How did it do that? You ready? Hey, Excel, if A13 is equal to $A, $2, and if you look back, that's AUS, period, is exactly in that cell, matches perfect, I think, comma, do this. Meaning, oh, that's Austin? Then use the VLOOKUP, that's going to refer to the Austin map. If it doesn't match AUST, don't forget an if statement. The first thing past the question, here's the question, is if it's true. Comma is the second thing if it's false. The second thing says, oh, it's not Austin? Well then, let's see if it's one of the other two. If A13 now is San Antonio, S period A period. It looks and tries to match. If it is, it will use the map made for San Antonio, which is cell locations D6 through F8. If it's not, then it must be, this is the other one, off Houston, then it must be Houston, so use the map for Houston. Look at this Excel statement. Now, if this were a question on the quiz, I would consider this a very hard question because there's a lot involved. But I do want to prepare you because if you're given an Excel spreadsheet like this, whoops, where'd it go? And you can see all this at the top. Let me even show you more at the top here. Okay? Looks like that. You could easily be asked, what would you write in this cell location to make a number like that come back, representing direct labor cost. And you have to tell me that Excel function that's written right there, which would be equal to, equals, VLOOKUP, parentheses, RAND, parentheses, comma, that's right, A, whatever, colon, C, whatever, comma, 3. That's what you got to be prepared for. What would you write in that one? What would you write in that one? And believe it or not, I may ask you what you have to write in here. Let's talk about this. If this is profit, it's looking at these and doing something with these. And I would say it's probably saying demand times our selling price minus our overhead 400,000 minus our overhead 600,000 minus demand times our labor cost minus demand times our parts cost equals profit, right? I took revenue minus the variable cost, and minus those fixed costs. That's unbelievable shocking that if we sell 18,000 of these, which is above 15,000, but if we sell 18,600 of these, that equals this large overhead of $1 million, and this cost of 90 for the parts and 45 for labor that we still will make, does that say $1 million? 1,128,000. That, well, you can see the selling price is so much more than these two added together. That's where it's coming from. Nice. You see how to prepare for this, though? All right, that's all I've got for today. So we'll pick up from here, those 2 subjects from the other chapter, and finish this chapter on Thursday, and we'll go over the quiz in detail. That other class we'll take.